boa noite a todos, ou boa tarde ainda, 5 horas da tarde, com pouco sol. Eu gostaria de começar fazendo alguns agradecimentos. Bom, antes de mais nada, a visita da professora Beatriz Pateiro, que está aqui conosco, de Santiago de Compostela, para ministrar esse curso, essa parte do curso, foi proporcionada através do generoso suporte da Petrobras. Em particular, gostaria de agradecer o Fernando Ayub, que está aqui conosco, que é a contraparte na Petrobras de um termo de cooperação muito importante que nós temos entre o INPA e a Petrobras. Então, isso proporcionou esse mini curso e vários outros produtos que estão sendo desenvolvidos com o passar do tempo. Bom, gostaria de agradecer também a Fátima Russo, que organizou e permitiu que algumas coisas de último minuto não impedissem que esse curso acontecesse, a Sônia Barros, que deve estar andando, correndo por aí de um lado para o outro, e ao pessoal de suporte do INPA, em particular o John, por essa colocação aqui do equipamento de audiovisual para que fosse possível a gente filmar, gravar essas apresentações. Bom, isso dito, eu vou mudar para uma língua mais saxônica em alguns minutos, mas antes de mais nada eu gostaria de agradecer a presença de todos e espero que vocês continuem participando das nossas atividades. Essa é a primeira das iniciativas que a gente tem especificamente na área de R, mas isso é um projeto nosso de desenvolver software livre, e R é uma, como vocês sabem, uma tremenda contribuição ao software livre. So, I'm going to switch now to English. It's my real pleasure to present to you Professor Beatriz Pateiro Lopes from the University of Santiago de Compostela in Spain, and she's with us for about a week to teach this first part of the introduction to R. It is, well, she's a specialist and well-renowned researcher in the area of R, and so I think that this is a great opportunity, and I thank you very much for your presence here. So please, the floor is yours.
Okay, so first of all, thank you very much for this invitation. It's a pleasure to be here with all of you. So let's start with this course. It has two parts, and the first part is about basics on R. Well, this is the outline of the course. I will give today an introduction on this program, and then we will talk about working with data in R, plotting with R, and also programming. And then some special parts in regression, numerical optimization, and in the end, something about RStudio. We will also work with RStudio from the beginning, but I will talk a little bit in the end of this course. There are some hints and tips in R that we will talk about during the course and the references. Well, so in this first part, in this introduction, I will talk about what is R, how to obtain it, and how to look for help and documentation on the program, and some basic things about the default system, the working directory, and package manipulation. Well, so this is the main web page. If you need anything about R, then this is the place where you should go first. There is everything in there. And this web page, I think I have here connection. Or no? It was this.
No, C-A-S-T-O-R-N-S.
Well, Well, maybe you can try from your computers with this page. I can try it later anyway. Well, this is the main page where everything about R is. And what is R? Well, you can find information about what is R in this first part of the web page. R is a language and environment for statistical computing and graphics. It is similar to the S language, and it was initiated by Robert Gentleman and Ross Ihaka, and I think that the name R comes from the initial of these names, and has been developed with contributions from all over the world since mid-1997. And it provides a wide variety of statistical and graphical techniques, and is highly extensive. We will see it later. There is a great number of packages developed by the community. And this is mainly the most important thing, is available as free software. Well, the R system consists on two major parts. The base system, and this is what you need to install for the first time, and there is also a collection of contributed packages. Well, everything can be obtained via this CRAN, which is in this part of the web page. You have to choose a location in this CRAN, and then for most users, it's sufficient to download and install precompiled binaries for base distribution. I think that I can skip this part because you have R installed in your computers right now, I think. Okay, so you run the setup program, and then R is installed in your computer. If you need something about the installation or administration of R, then you can go to this documentation here. I will talk now about the references on this presentation. I have added a lot of books. There are many more about R, but these are the main that I used to write this presentation. So these are books for introductory statistics with R. There are also some books more applied to, for instance, econometrics, like this one, and you will see more books, more specialized books in finance with R in the second part of this course. So this part is for basics on the programming with R. You have many books. You have also, or I have also chose some lecture notes. For instance, in this web page, you can find keynote lectures and presentation from the International R User Conference, so this is quite interesting. There are also some lectures from professors in different universities here, and I also added some online resources. Blogs, there are a lot of blogs where people write about different things in R. There is also this RSeek, which is a search engine for like a Google, but only for R, and well, maybe you can find useful these web pages here. Okay, so first I will talk about different documentation for the R system, and this is from the main page. You can try in this R project page. You have on one you have electronic manuals. You can find them in this link. I will try now, but I think that is not going to work. Okay. Okay, so here you have manuals on R, for instance, for an introduction, and I will talk about this manual later, for import and export data, for the installation administration. This is the one that I mentioned before, and different manuals on R. But you have also, in this web page, a wide collection of books and other publications related. So these are some of the books in R, and you see that there are a lot of them. Some of them are in the references of the presentation. There are also frequently asked questions. So this is another good place to look for information about R when programming. And there is also the online help that we will use when running the program. Okay? But these are different sources of information on the program. Well, so let's start with R. And in order to run R, we click on the R icon, or I have Windows, so this is what I see when I run R. Maybe if you have a Mac or you work with Linux, the view is different, but essentially you have the same. You have this part, which is the main part in R, which is the R console. Okay, I will change, and here we have, for instance, here when I write this is a hint. So in this case, I go to the first one. If you want to change the settings or the default settings or this arc guy, you can edit the preferences. And this is what I'm going to do first because you can't see anything from there, I think. So I will change here, edit, preferences. Okay. So everybody can see from your place. Okay, so this is the, well, the hints and tips are, well, small things that you can find useful, but it's not important for the programming thing, I think. Well, so this is the R console. This is how I see it in Windows, and here it appears the prompt, and this means that R is waiting for you to type something. Okay, so first we can, for instance, use R as a simple calculator. So 5 plus 6, this is 11. 5 times 6, this is 30. So this is the first thing that we can do with R. Just use it as a simple calculator. For instance, we can write or we can compute the square root of a number, and for this we have to use a function. And this is the first function that we are going to use in R. And to compute the square root of a number, I have to write sqrt, and in parentheses the number that I want. Square root of 9, and this is 3. Okay, and the first thing that we see about the functions in R is that a function is a name of the function, and between parentheses we have to put the arguments in. Okay. Well, and there are many other functions. For instance, the logarithm of a number. This is logarithm of 7, and I have here in this presentation other simple functions that you may find useful, numeric functions, the square root, the exponential function, a logarithm, natural logarithm of common logarithm of x, absolute value, sinus, cosinus, etc. Okay, and all of them have the same. It's a number of the function, and between parentheses I have to write the arguments. Okay. And now we are going to talk about how to use or how to get help in R, online help. So, for instance, there is different types of helps in R. We have a general help, and we can get it with this function, help point start. If we write this, help point start, then it goes to this page, and this we have general help of the program. The introduction, the documents that I showed before, installation and administration, etc. And here some other references and material about R. This is the general help. But there is also help about functions. For instance, if I want to know how the log function works or what the function log does, then I can write help, and between parentheses the name of the function. Okay, so help log, and this gives me a new file with help about function. And all these help files have the same have the same structure. So we have here, well, a title for the help, the description of the function, for instance, log computes logarithms, by default natural logarithms, etc. We have here the usage of the function, the arguments, and we will talk later about arguments of a function. But we have here the usage, the description of the arguments of the function, So for instance, when I do log of x, x has to be a numeric or complex vector, etc. Well, sometimes these files have details on the function that they are described, and also here at the end, sometimes you find references and also examples on the usage of the function. So you can copy these examples here and run them in the console. Okay? And every time that you ask for help of a function in R, you get something similar to this. A description file with the usage, the arguments, some details on the function, references, and examples on the usage of the function. Well, there is another type of help. I mean, we have help point start to a general help on R. We have help of a function to get an information about a function. And we have also, you can also list all functions containing a given script. For example, with this one, apropos, and you need to write it like this, apropos log, it lists the functions in R that we have right now, that we can use right now, that have this characters log. So for instance, in particular, the log function, but also log 10 or logic or different things. Okay, so apropos is to get help with a sequence of characters. And for instance, we can also show examples of a function with this example log. These are the same examples that are shown in this file page, in this page. But if you write example and the function, then you copy the examples and run it into R. Okay, so this is some of the online helps that you can get in R. The main one is the help function, and it's the same as question. This is exactly the same as help log. Okay. Well, if you have any questions, please ask me whenever you want. You can interrupt me to ask. Well,
changed to the source of power.
So?
Don't panic, it's just a change of
Okay. Well, so up to now I have only made some computations, 6 times 4, things like that, square root of 14. But we can also assign values to variables and refer them by a name. So for instance, I can keep in x the value 3. And this is the way in which we assign in R with this arrow. Okay? So I make x equal to 3, and when I write x, then x is there and x is 3. Okay? Well, we could also use this equal to assign a value, and here y is 5. But well, for the main things that we are going to do, there is no difference between this and this, but I prefer to use this all the time because, for instance, equal is used to assign arguments to a function, and there are some difference between them, so I'm going to try to use all the time this to assign a value to a variable, okay? Well, and another thing which is quite important is that R is case sensitive. So I wrote lowercase x, x doesn't exist. Okay, so they are different, and this is something that we have to be careful because when we write names of variables, sometimes it seems that, I mean, we have problems or we commit mistakes because of this thing, that R is case sensitive, so it distinguishes between lowercase and uppercase. Well, another thing that I didn't mention before is that sometimes, for instance, if I want to do this operation 3 times 5 minus 4, well, this is done, but if I write like this, okay, then this symbol appears. When we get a plus in the command line, it means that R is waiting for you to continue because this didn't end, so it's waiting for you to continue with the command. So if I don't do anything, then it continues until I write something which it doesn't make sense, and then it says there is an error here. Another thing is that you can go up, you can obtain the last things that you wrote with the keys in your keynote, okay? So if you go up and down, then you get the last things that you wrote. So I come back here to this expression. Then it's waiting for something, for instance, for 2, it's still waiting for something. I close the parentheses, and then it's finished, okay? These are things that you may find when you write in the beginning, that you didn't end a command line, and then this plus appears, and you don't remember why what this means. This just means that R is waiting for you to end the command line. Okay. And I was talking about the objects, and I have this X, and I have created Y, and these are numerical variables, but I can also create character variables. For instance, my name, and my name is Bea. And this is the way in which I write characters in R with this expression like this. And my name is stored, and is Bea, and X is 3, and Y is 5. And I also can create logical variables, and this is done. For instance, this is going to be true, or W is going to be false. And these are, these are logical. I cannot use true as a name of a variable. This is an error, because this is reserved for logical constants. Okay? And I can also use T for true or F for false, and R will understand that you are writing logical variables. Okay? The problem is that I can use this. This is something that I can do. T is 5, and if I do this, now this is 5, not logical. Okay? So you can always write the complete word which is reserved to be a logical. Okay? There are also some special values in R. One of them is the NA value here. This is going to appear when we read, for instance, a data set and there are some missing values. So in that case, it's going to appear not available, NA. Okay? There are also infinite and minus infinite. For instance, if I do this operation, this is an infinite number. If I do this operation, this is minus infinite. And if I do the square root of a negative number, this is not a number. So we have NA, not available, inf, minus inf, or not a number. These are special values used in R. Well, so I have written some variables here. If I want to know what objects I created, then I can use ls to list all the objects which are available right now. Okay, and this is my list. Maybe you have something different depending on what you have written. Okay. Well, this is the same as objects. These are the two ways you have to list the objects in your working directory. Okay, I can remove, for instance, if I want to remove X, then I use RM to remove X, and now X does not exist, or X is not found. Okay, and I can quit R with Q. Q, I exit, and it asks if I want to save my workspace. I will say no this time, and then we'll try with different options. Okay, so I say no, I quit, I start, R again, I have nothing here. Okay, I will change this view. There is nothing here because I didn't save the last session. But I'm going to write here x equals 6, y equals 7. I have these two objects here. Okay? I will quit. But I'm going to keep saving the image, so I will say, well, I will quit, and when it asks me, I say yes. I said yes, so now you have the objects here. But this is not the best thing that you can do, because anytime you start R, then you have these objects here, and maybe you don't want to work with these objects in this case. So I'm going to remove everything, and in order to remove everything, I use, okay, I will change this again. I remove everything, list equal ls. This is what you have to write in order to remove all the objects that you have. I have nothing. I quit saving. And I have nothing, okay? And this is, well, this is how I like to work with R, with nothing in the working directory, okay? But now, if I want to save anything but in a different place, for instance, if I have my folder where I work in a project and I have the objects of that project, and I want to have them, then I can do like this. I have X, and I want to keep this, so I save the image. Okay, and this is save image, and then I'm going to write the name of the image I want to save. And the name, for instance, in my case, is my workspace. The extension is R data. Okay, these are the extensions for the image files in R. So I save this, and the thing is where this is saved. To know where this is saved, get wd, get working directory. It says where R is working right now. Okay, get working directory. So this is in my user documents. Okay, I'm going to quit without saving anymore. I'm going to that folder, the users documents, okay. And here I have my workspace, okay? And if I open this and I list, I have X, okay? Or if I open R, but here there is nothing, okay? I can load the workspace that I created by load.image, but here I have to give the complete path to the place where the workspace is saved. Okay, I'm going to do it, or load, sorry, this is just load. So this is here. I have to change in Windows at least the slashes. Okay, and this is my vspace.r data. Now I have X. Okay. Well, so an important thing here in R is the working directory. It's the place where we are working on, or where R looks for the files or for the workspaces or whatever. So I said that in order to know where we are working in, I say get WD. Now I'm working in documents because this is where I have my workspace. Okay, so this is the place where I'm working. So now, suppose we want to set a different workspace, for instance, and I have here users, documents, my documents. I created here this folder artwork, and maybe you can also create a folder like this, because this is the place where we are going to put the files that we are going to read into R and different things we are going to work with. So I have this file, this folder here, artwork, and this is the place where I want R to work. Okay? So I'm going to set the working directory in R to this folder. And to do that, what I have to do is to use the function set WD, set working directory. So get WD is to get the working directory, set WD is to set the working directory. I'm going to set this working directory to this folder. Now if I ask R, where am I? R is working in this folder, artwork. Okay, questions? Or maybe I'm going too fast or too slow? We can also write dir to get the files inside the folder. Maybe you have nothing because you have created right now the folder, but I have some files inside. So this is what I get when I use dir, a list of the files in the directory. So if I ask now R to look for something in a file, R is going to look for it in this folder. So the usual way I used to work with in R is that I create a folder for a project, I put in that folder all the files that I want to work with, and I put R working into that folder, changing the working directory with set WD as I did right now. Okay? And I don't use to save the image as I did before, because what I do is to write the code and I reproduce the code every time I want to run R. And then I don't have to save the objects. I only save the code, and then I reproduce the objects anytime I want running the code, which is simpler. Okay? So it is a good idea, as I say in the slides, it's a good idea to save the workspace, the R data file, only if your calculations take a long time to complete. Otherwise, rather than saving the workspace, it is more convenient to keep a record of the commands we have entered, and then we can reproduce the objects in the next session, compiling the code. Okay? Any question? No?
One question that how can you direct it to
know several paths. Like, for example, if I want to get programs from one path and from another path.
Yeah, for instance, if we are going to read files, if you want to read a file which is in a folder, then you can write the complete path to that folder. It's easier if you put the file in the folder where your working directory is, because then you don't have to write the complete path to that folder. But you have always the option to write the complete path to the place where you have to do something in a particular moment.
So it does not recognize different paths. Like, for example, you can say directory 1, directory 2, and directory 3, and look for comments or functions in those.
Yeah, you have to write the paths.
Okay.
You only have one working directory, and if you want to work with something different, then you have to run the path or change the working directory to that place. Mm-hmm. Okay, so I said that the simplest way to keep a record of the commands is to enter the commands using an editor. So instead of writing here, what I'm going to do is to write a script with the commands and then run the commands into R. So this console at the end, we are not going to use this all the time. So to write a script is just a file, a text file. In Windows, R has its own editor, but this is quite simple. It's just like a note, like the notepad. Okay, so I can write here whatever I want. For instance, I can write x equal to 4, y equal to 5. I don't have to write the prompt here, okay, so just the commands. And then I'm going to run this code in R. To do that, I can use Control A in Windows to select all, Control R to run. So if you see, these two lines here are now in the console. It's like copy-paste to the console. And now I have here X and Y. If you work with Windows, you can also do the same thing from these buttons here. Edit, run line or selection, run all. And also these things about get WD, set WD, etc. In Windows at least, you can do it from this file, from the console, file, save workspace, load workspace, load change dir. Okay, if you use this and you browse the folder where you want to put your working directory from this menu, then you do the same as with get, with set WD. Okay, but in Linux, for instance, I think that you don't have something like this, so you have to write the commands. And okay, so this is it. Okay, I'm going to write a first script with a little more, with more things. File, new script. I'm going to write. We are going to do a first plot. So this is. We will see these commands later, but I'm going to write a sequence of numbers from 0 to 2 times p, 100 numbers between 0 and 2p, and y it's going to be the sinus of x. And I'm going to plot x versus y with a line, type equal L, not 1, L. Okay, I can do this, Control A, Control R, or select and run everything, and the code is compiled, and I get this first plot of the sinus function. Okay. Well, the next time that I run R, if I want to do the same, what I should do is to save this R script, File, Save As. It's going to try to save it in your workspace. So I'm going to save this as first script, for instance. This is, first script. You save it. And you can open again the file and run the code, or you can source the file from the command line. So I can do source, the name of the file where the code was first script, the extension was R, but you can also source a TXT file, for instance, okay? Okay, so if you are writing a code, then what you do is you have your file and you select and compile. But if you have written a function a long time ago, then you don't have to open the file, you source the file from the command line or from another text file where you are working and doing different things. And the important thing here is that the file, if you write the file like this, the file has to be in the working directory. And if it is not in the working directory, you can or change the working directory to the place where the file is, or give here the complete path to the file where the code is. These are the two options that you have in order to source a file. Okay? Questions? Okay. Well, so let's move to a different thing, which is to packages in R. Well, all functions in R and all data sets in R are stored in packages. Only when a package is loaded are its contents available, where some packages are installed in R and automatically loaded at the start of an R session. This is why we can use the sqrt function, for instance, or the log function, because the package where those functions are written are installed and automatically loaded when we start R. The standard packages contain the basic functions that allow R to work, and the data sets and standard statistical and graphical functions. Well, these packages are the base package, where functions such as the sqrt, the square root, are defined. The graphics package, for instance, the plot function that I used before, is included in this graphic package, and this package is loaded and installed from the very beginning. You don't have to say anything to use these functions. And also the stat package, which provides a broad range of statistical functionality. For instance, if you want to compute a mean or a variance or, well, anything, you don't have to do anything special. The functions are included in the installation, and you can call them and use them without doing anything extra, okay? Well, this function library, without any arguments, gives us a list of all currently installed packages. So what I get is going to be quite different from what you are going to get, because I have installed many packages, and if you have the basic installations, you have few packages installed. So I type here library, and I get all the packages that are now installed in my installation in R. So I have the base package, but also the boot, Kairos. Maybe you don't have this one, because we are going to use it later when talking about graphics. Well, as you see, I have many packages installed, and you have some of them, okay? Well, there are thousands of contributed packages in R. If you go to the R page, here you have packages, available packages sorted by date of publication, and this is what you see. These are all the packages available right now. So everybody now writes a package, okay? Well, If I want to use one of these contributed packages, then I have first to install it and then to load it. Okay, so we are going to do as an example, we are going to install a package which is called RUGARCH, and this you will use this package in the second part of the course because it provides methods for modeling GARCH processes, including fitting, filtering, forecasting, simulation, and diagnostic tools with plots and different tests. Okay. If I want to install this package, what I have to do is to write here install point packages and the name of the package that I want to install. Well, you will have to choose a mirror. I choose Austria, for instance. And now I have the package installed. And the same for any other package that you want to install. Install packages and the name of the package. The thing is that I cannot use the functions inside this package because it is only installed, but it's not loaded into R. Okay? So anytime that I want to use a function inside this package, I have to write library and the name of the package. Okay? In this particular case, this package has some dependencies, so it's loading other different packages. Okay? And I have to write library RUGARCH anytime I want to use a function inside this package. I don't have to start it more, but I have to load the library, I have to load the package anytime I want to use a function included in this package. So if you close R and in the next session you want to use this package, you will have to write again library RUGARCH. Okay? Everybody has the package installed? Well, I said before that this function gives us help about a function. I write help log, and we have help about the log function. But we can also get help about a package in general. Yes?
Excuse me, do you know the Wi-Fi password?
Over there. It's written over there. Just read.
But I'm old and my eyesight has gone bad. Okay, thank you. Sorry.
Well, so the help function, I can use the help function to ask for a function or to ask for a package. But in that case, I have to write package equal and the name. Okay, so help package equal opens something similar as before, but about a package. Okay, I installed the package RUGARCH, I loaded it with library. If you don't write library, then this is not going to work because you have to load the package besides installing it. And if I want to know what the package contains, then I ask for help about the package. And this package contains a lot of functions or data set of different things, and this is the list of the contents of the package RUGARCH. Okay, these are functions, different functions, or there are also data sets, I think in this Okay. Well, and there are also a different help, and many packages contain what we call, well, I don't know how to pronounce it, a vignette or vignette. This word. Okay. I can see with this function without arguments, I can get a list of the packages that I have installed that contain this kind of information. Okay? So here you have, for instance, I have package format R. I don't know if you have this package installed, but if you go down, I have many packages here, but in particular, I have this package, RUGuards, and this package that we have just installed contains just one vignette. I can read this vignette if I write the name. First I get the name of the vignette with this command, and now I know that the name of the vignette is Introduction to the RUGuards package, and I ask for it. And then we get this, which is a PDF, and these kind of files contain information about the package, but not only the functions or the usage of the function. Usually they contain methodology about what the package is for. So in this case, you have here information about different models or GUARDS models inside this package. So these files are also quite useful because it's not only the functions, it's also some methodology about the package. Okay? And there are many packages that contain this kind of information. Well, and the packages also, they contain functions, but they can also contain data sets. So if we want to know the data sets that we have available right now, you can write data without arguments. It's always the same. Vignette without arguments, give a list of the vignette. Library without arguments gives a list of the packages which are installed. Data without arguments gives a list of the data sets that we have access to in this moment. Okay, so in particular, this datasets package is installed by default, but if you go down here, you will have package RUGuards, and this package contains 3 datasets. So in particular, if I'm interested in this one and I want to know or I want to get some information about this data set, I can write help, as always, with the name of the data set. Oops. With this, I get the data sets available. I see that there is a data set with this name. I ask for help about this data set. And I get this file here with a description. This contains with the closing value log return from 1987 to 2009 from Yahoo Finance. Okay, it has not many information, but I can see what is inside the data set. And in order to use it, I cannot write the name like this. This is not found. I have to load the data set. And in order to load a data set, I have to write data with the name of the data set I want. And now, I have the data set if I want to work with it.
I have a silly question. What to do if the package depends on an older version of your installation? Because my installation of R is So
Yes, the best thing is to work with the last version, but if you go to this, to the page, to the R page, and you have, for instance, well, this is by date of publication, so this is not going to work, but by name, regards. You have these all sources, so maybe from this you can get an older version that works with an older version of R. Okay? And if you download a zip file like this, you can install it from here. Packages, install from local zip file. So you download the file and you install it from this option here. You search in your where the file is and you load that version. Okay. So we have seen how to install a package, we have to install it and to load it, how to get help about a function or about a package in general or about a data set, and how to load data sets included in different packages. And in order to use a data set, we have to load it before with data, the number of the data set, the name of the data set, sorry, and then we have access to this to the data set, as in this case. Well, I'm working with this this installation of R, but there are also, this is, well, maybe you realize that this is not very nice, because when I write code, for instance, I cannot distinguish with colors different parts of the code, and well, it's not the best, it's like a notepad at the end. So there are some editors or external editors that have modes for highlighting our syntax, for example, and executing code directly from the editor. And I chose here some of them. The main one, I'm going to talk about RStudio and to work with RStudio is this one, but there are also other possibilities. For instance, Notepad++, if you install this application, then you can run code from the Notepad to R directly, okay? Also, there is ThinR, which was very used, and if you work with Eclipse, for instance, for different platforms, you can also install this stat.ed to run R code from the platform, from Eclipse, for instance. And there are many other possibilities, but maybe this is the most used, RStudio. You have here the web page to install it and to read the documentation about RStudio. The good thing about this platform is that it's free and open source integrated environment for R, It combines all resources required for programming in R in a single window. I will open it now and you will see how the things are distributed. And well, the standard layout consists on the source core, on the source editor, the workspace and history pane, the files, help and graphics browsers, and the R console. The tools and features about RStudio is that it's multi-platform. You can use it in Windows, Mac, Linux. It has syntax highlighting, code completion. You can execute R code directly from the editor. It has the R help system integrated into the program, and it supports Swape, NeedR, Markdown, and LaTeX. And I will talk about this in the end of this course. This, for instance, this presentation was written using RStudio. And I didn't have to copy and paste these things from R to my Beamer presentation, and I didn't have to change the colors here, because with this application in RStudio, I can say this is code, it runs it, and then it puts the colors here, and it plugs the figures, for instance, directly from R to the Beamer, or from R to a LaTeX document, for instance. To make a paper, to write a paper, for instance, if you have to use some simulations or things, you don't have to write your document in a part and then R and then mix it together. You can work with RStudio, and at the same time you write the code is plugged into the LaTeX file, or if you make a plot, the plot is directly plugged into the file, so it's quite useful. And this is RStudio. If you have installed it, then you already know the appearance of the program. Well, by default, I have here the R console. We have here the workspace. Here you have the objects, and there is nothing in this case. And here we have plots, or the working directory. I will show how to install packages from RStudio. We see it's much simpler, and also the help is integrated in the program. Okay, so if I write here x equal to 5, I have here the objects that I have created. Okay, I can also create a new script here. Well, I'm going to put this also larger. I can run the code directly as before. Control A, Control R to run the code is here right now. I can ask for help, for instance, help on the plot function, and now the help is integrated in this part of the program. If I do a plot, well, this doesn't make very much sense, but if I do this plot, then I have here integrated also the plot in this part of the program. I can change from one to the other.
So is how you call the source actor?
How, sorry?
The source actor we provide, how do you call it up?
To compile this code, I do call Control A, Control R.
How did the window appear in the first place?
File, New, R script.
Thank you.
Here you see that you can create different type of files. For instance, RSWave is to create a document in LaTeX combining R with LaTeX. Markdown is to write presentations for in HTML. There are many I see if I can find anything here. Well, this kind of files in HTML where, like a tutorial, for instance, you write something and then you show the code to write what you want, and then you get a plot of the things that you did. This kind of document is a markdown document, and you can write it also from here with this option, okay? But what we are going to use mainly is an R script, is where we just write code in R to compile to do different things. And if I want to install a package here, I can use the same option as before, install point packages, but I can also do it from these part packages, install packages. I look for instance, this one. For instance, this package AER. Install, and you see it does the same as we did before, but we don't have to write anything. Okay. Well, so we will start now. It's installing the package. With basic manipulation in R, how to enter or import and export data. Well, we have seen how to load data sets which are included in the package or in a package with the function data. However, we used to work with our own data sets. So we will describe different ways to import data into R. R can import data from text files, from other statistical software, for instance, SPSS, from spreadsheets as Excel or OpenOffice spreadsheet, or even from a web address. So we will see how to do these different things. Anything you want to know about data importation, about importing or exporting data in R is included in this document, and also in chapter 12 in this book, you will find a good description on how to import data from different sources in R. So we will start with the simplest case. So the simplest way to store data is in a plain text file. And we used to store in columns the variables and in the rows the observations. So the function that we are going to use to read data in a text file in R is the function read.table. Okay? This is the most convenient way to read in a rectangular grid of data from a text file. So we will first check the help file about this function, and we already know how to do it. We write here help on this function read.table. And here you get the description of this file. It reads a file in table format and creates a data frame. We will talk later about what a data frame is. From it, with cases corresponding to lines and variables to fields in the file. And this is the usage, read table, and in parentheses, different arguments of the function. Okay? Well, there are other options that we will comment later. And here we see the arguments of the function, and there are many of them. Okay? So in order to try this, this function, we are going to use some of the files that I sent. There is a zip file, I don't know exactly the name, but it contains different files, for instance, data 1, data 2, I don't know if there is a data 3, I don't think so. But you should keep those files in your working directory. I put them in our work because this is the place where I want to work. Okay, but first of all, you unzipped the files to a folder. The next thing that we should do is to change the working directory to that folder, and that way we don't have to write the complete path to the place where the files are. So I'm going to do this first. So set WD. So I'm here, I list the files, and in particular I have this data one, which is the first one that I'm going to read, okay? Well, but we are going to talk about this function read point table. Here you have the first argument of this function is the file. So this is the name of the file which the data are to be read from. Okay, this is the first argument, but there are also many other arguments that control the format of the input file. For instance, and these are the arguments that we usually use, this header argument, it indicates if the data file contains a first line with the column names, with the names of the variables. This sep argument, it indicates the character that separates the columns in the file. Dec, it indicates the character for the decimal point. It depends if we come from a file in Excel, for instance, then the decimal point is going to be a comma, or if we come from another program, then it's going to be a point, like in this case. Well, there are many arguments that we may have to use in order to read correctly the data, okay? So I'm going to take the opportunity to explain something about the arguments in R. So there are some arguments in R which have default values, and some arguments without default arguments. So for instance, in this case, file has not a default argument, but header is set by default equal to false. So if I write this file, if I call this function and I don't give this argument, then R is going to understand that header is false and and is going to work with this argument. Okay? So we only need to give those arguments that are different from the default, okay? And there is also an important thing about the order in which we give the arguments to the function. So what R does is that it takes the arguments that we give to the function and it puts it in order, in the same order as they are defined here. Okay, so the first thing that I give to the read point table function, R is going to understand that is the file name. Okay, and if I gave a second argument, then it's going to try with header because this is the second argument of the function. Okay, so we will try to read this first data set, which is quite simple. This is data one. I'm going to open it before to see the structure of this data file. And I see that this has, well, a first row with names of the variables. Then we have 5 rows with numbers. If you see, the character that separates the columns is a white space, okay? And the point, the decimal point, the character is a point. And here, well, this is this 4th row, it has something missing here. It has only 2 numbers when in the other cases there are 3. Okay? So we want to read this data into R. This is a text file, very simple, so I'm going to use read point table. If I do like this, data one, I think this was the name, data one, this is a text file, txt. Here there are some problems. Okay? Well, the first thing is that it's trying to read with these arguments here, and there are some problems because, in particular, the file has a row name. It has the first line with names of the variables. So we have to specify this in R because, by default, this is equal to false. Okay? So the first thing that I'm going to do is this thing. Well, I still have some problems, but at least he knows that the problem is in the 4th line, not in the 5th one, because now it identifies the first row with the numbers, with the names of the columns, okay? Well, the other thing is that how I call this argument here. I could do this thing. I could write like this, okay? Because there are 2 arguments, this is going to be the first one, and this is going to be the second one. So it comes to the definition of the function. This is the first one, this is the second one, everything is okay, okay? Now, another thing, this, by default, there is no separation. I should specify that my separation SEP is a white space. Again, since SEP is the 3rd argument, I didn't have to write the name of the argument, okay? But I'm going to do it because it's easier to understand later, okay? So this is header, and this is SEP. And another thing that I can do, I could do like this. SEP header. If I give the name of the argument, then I can change the order. There is no problem. R knows that this is the argument SEP, this is the argument header. There is no problem with the order in which we give the arguments, okay? So we have these possibilities. If we know the order and we give everything, then without names. If we change the order, then we have to be careful to give the names. And another possibility is that we could write something like this. Instead of header, I can write head. If there is no another argument beginning with these 4 letters, there is no problem. Maybe with this is enough. I don't know all the arguments here if there are others with this. Okay, so I can write the complete name or just a part of the name if we are careful that there are not other arguments beginning with these letters. We can give the arguments in the same order as they are defined, and then I have not to give the names. And this seems to work, right? I'm going to keep this in an object, that one. I'm going to write here this object, and I see that this first line, it identifies that these are numbers because it has not a number, these are names because it has not a number in the left. So the first line with data is 1.2, 2.5, 3.6. And here it appears what I mentioned before, this is not available. In this 4th line, the second element is missing, and this is identified by R as not available. Okay? And this is correct. The decimal character was a point, and this is the default value in the definition of the function, so I don't have to specify this argument, for instance. So with these 3 arguments, the file, the separator character, and the header, which is true, then I read the file. Okay? And I can write, we will talk tomorrow about type of objects in R. The class of these objects, of this object is a data frame, which is like a matrix, but it can contain number and characters also. So it's a combination of quantitative and qualitative variables. Okay, so this is the structure that we use in statistics the most, a data frame. Okay, so we have read this first data set. More things about this data set. For instance, we will see many functions. dim of data 1 is the dimension, that one, 5 rows, 3 columns. And we could also, and this is what I write here in the slides, that you can read the file given the complete path to the file, or what we did right now, we changed the working directory to the place where the file is, and then when importing the data, I only have to give the file name, okay, without any other arguments. And this is what we did with the default arguments. And now we are going to talk about different options. As we saw, the read.table function is very flexible, so allows to load files with many different formats. So are included a set of functions that what they do is to call read.table or read.table, sorry, but with different default options for some arguments. So for instance, if we use read.csv, then what it uses by default is header equal true, sep, comma, dec, appoint. Or if we use read.table, then by default, header is false, sep is a white space, dec is a point. So maybe if we try with read.table and our data 1 without any other argument, this is going to work, because it's like calling well, this is what we used. I mean, this is, this is a white space here, is a header equal false, this doesn't work, sorry. But I have another data file here, data2, so we can check the structure of this data set. Okay, so this is another data set. It has a first line with the names of the variables. The columns are separated with a comma, and its number, the decimal point, is a dot. So if I want to read this data set into R, first I can use read.table, the one that I used before. And what should I say? Well, this that2 is equal read table. The file is data2.txt. Well, I have to say that it has a header. Header is true. I have to specify the separator character because it's a comma, is different from the default value, so this is a comma. And I think that nothing more because the decimal point is a point, so this is okay. I read that too. Well, this is too long, so if you want only to see the first part of a data set, you can write head. And this gives us just the first 5 lines of the data set, or 6 lines. So this is correct. These are the names of the variables, and these are the contents of the data set, and everything it's right. Look what happens, for instance, if we don't specify the header. It reads something, but this is not correct, because it understands that the first line is data, so it creates variables v1, v2, etc. And now the problem is that this is not a number anymore, because it has to be a character as invest. So it seems that it works, but it's not working, okay? Or if we don't write, we write the header, but we don't write the separator character, well, it has problem with different things, or maybe it doesn't separate the columns, or different things. So maybe like in this case, the command works, but the result is not what we want. So we have to check that the file is read correctly. Okay. Well, but I said that if I have these options here, header, true, sep, comma, and the decimal is a point, then I have another option. Instead of read point table, I can use this one. Okay, because these are the default values that I want to say. Header true, sep a comma, dec a point. So I can use read point CSV data to point txt without any other argument. Okay. So for instance, if you save a file from Excel, then you can save it as a CSV file with this format, and then the easiest way to import it into R is with this read.csv function without any other argument than the file name. Okay, and you don't have to specify any other thing. But you always have the option to write this, to use this function and specify the different arguments in order to read the files. Okay? Well, we can also read or use the same function, read point table, to read directly from an URL by giving this URL as the file argument. For example, I chose this website, Brazilian Institute of Geography and Statistics, and here you can find a lot of series, and I don't remember. I chose one of these, and then once you choose different options, then you can share planilla Excel, okay? And this gives you, well, you can save it, but you can also save the link to this file, okay? So I did this, and I chose one of these data sets with this option, and here I have the complete URL to this data set, and I can use it to read it directly from R. If I check the file, I can see that the format of the file where the data is stored has these characteristics. Okay, it includes a header, the separator is the tabulador, the tab, and the decimal point is a comma. So instead of using read point table with all these arguments, I can use directly read point delim2 just with the name of the file, which in this case is not a file, is an URL. Sorry. So the only thing is that you can try this this by copying here, but what you have to do is to put everything in just one line, because there are problems with the return, with the if it's not everything in the same line. So you can copy and paste, but put everything here in just one line, like this. Now Control R, Control R, and head data 3. Well, this information, I don't remember exactly the series that I chose, but this is another way to do it, okay? More things. Well, we can also import data from, for instance, from Excel. The thing is that even if we can export directly from Excel, the easiest way to read data in this case is, as I say here, is to export it to a text file and use one of these options, read point table, or any of its variations. For example, we can export directly from Microsoft Excel or from OpenOffice Calc as a CSV. Okay, and then we can use this function to read into R. Anyway, there are options to read directly from Excel. This is an example, but this only works in Windows, for Windows users, and for 32-bit R. Okay, so I will have to, when you install R, you have these two options. Sorry. 64 and 32, you should use this one, okay? And you also need to install a special library, which is the library RODBC, okay? So this can be used to read directly into R. This is an example. I also sent this file, serie INCP-XLS. It's the same series that I read before from the URL, but it's saved into an XLS file. So these are the commands that you have to use in order to read directly from Excel into R, only for users of Windows 32 bits. So first you have to install the library. Once you install the library, you have to load it. So this is why I write library RODBC. The next step is to open a connection to the file where the data is stored. So this is with the function ODBC connect Excel and the name of the file I want to open, and this is saved to what I call connects. This is just for information. With this function, I can list the worksheet tab names. Okay? In this case, the file has only one tab. Well, I can try it here. So I'm going to first, I will do it directly with this. Okay. So first I will change the directory to the place where the file is. This is in our work. I think I already installed the library. Yes. Now I have to open the connects to the file. This is what I do with this instruction, with this command. Okay. This is just to know the names of the tabs. Okay, this is the name of the tab I want to open. And this is to fetch the data. So I tell R that in these connections, it has to open the tab with name INCP that I see here. I get this information or opening the file or asking for the information with SQL tables, okay? And now I have the data available here. And the last thing that I have to do is to close the connection, and this is what I do with this function, close connects, okay? Well, this is, for me, it's a bit weird because it's much easier to come to the file, open it, save as a CVS or CSV or a TXT file, and then open it with read point table. And I don't depend on Windows or in 32 or 64 bits or whatever. So the easiest way to read this kind of files is to save them as a text file or a CSV file and then open them with the read point table function or any of its variants. Okay? Well, any question or?
I couldn't install RODBC, the file isn't in the zip file that was sent.
Sorry, I didn't hear.
I could not install RODBC.
Are you working with Windows and with 32 bits, the R installation?
64.
That's well.
When Windows work like this, it can only work when
Yeah.
it doesn't work for Mac.
There are other options to import files not in Windows. This is the easiest way in Windows. There are other libraries or packages that to install. I mentioned some of them later to read from databases, in particular to read from Excel, but then you have to install drivers or things. I mean, it's more complicated. It's a little bit more complicated, and it's much easier to save the file as a text file, and it's done. But there are options for other users, but they are more complicated.
I installed RStudio and it offered only one option for Windows, and I think that option is
62. Yeah, I think that by default this works with. You should change the R that RStudio is linked to. But you can, if you want to try with this, what you can do is to work directly with R, not with RStudio, and open the 32 bits version, and then try to install the library. Because if you work with R, I think, I'm not sure, but I think that this, for default, works with 64-bit version. I think that there is some way, some place where you can change this, but I don't know it right now. So. Well, so it's 15 minutes late. We have 15 minutes, so well, I'm going to mention also this last part because there, for instance, if you want to read from another statistical software, for instance, if you want to read from SPSS or Stata or different statistical systems, you can also use this library, this package foreign. You have to install the package and then load it. And if you ask for help on this package, you will see that it has many functions to read from read point SPSS, read point different statistical systems, and it is an easy way to read data from other statistical software. And also, and this is related with what he asked before, R can communicate with database management system. So in order to connect to a database from R, you will need to install optional packages. In particular, there is this RODBC package that I mentioned before, and it provides tools to access databases through this interface. In particular, you can read from Excel, from Access, etc. And there is also this DBI package, and this is a set of different packages for accessing databases from R. This is more general. Anyway, if you work with Windows, you have to install drivers to work with it. If you work with Linux or Mac, maybe it's easier, but it's not direct. And in this document, you have information about these packages if you are interested in reading files from these different sources. Okay? And instead of continuing, I wrote some exercises here. I didn't put it in with the documentation that you have, but I have here this link to my Dropbox, and you can download them. So maybe these 10-15 minutes, you can work on these exercises and ask me any question that you have about the contents that we saw today. So it's about packages, help, opening files, etc. Okay, and here I have, I think, in this. This is not the best link, but Okay. There is a PDF file with exercises and a zip file with different data sets to try with these functions that we saw today. Any question or comment in general? Then I can walk over the class to see if you have any problems. Okay?
Connection's a bit slow now.
Well, I can open, for the first part, you can read from the computer. Tomorrow I will send the document to the... I can walk over here.
Yeah, sure. Yes, it's good. Yeah, watch.
I work in a bank for my team in the risk area, but we cannot all come at the same class. So and my boss asked if there is a particular class that's more important than others, then we all try